Hi, this is Dr. John Berghoff. In this video, I'm going to show you a surveying problem that can be solved using properties of similar triangles. So I'm going to outline this as I draw a picture. Suppose you have a river. This represents a river. It will represent little waves and so forth there, and you're wondering how wide it is. Now, measuring the distance across the river could be done directly with some sort of long device, but if this is a very wide river, that might be hard to do. So I want to show you a little trick that surveyors use. Let's suppose that you are on the lower side of the river down here, and you notice that there's a tree on the other side. So over here, you notice that there is a tree. What you do is this: you locate a spot exactly across from the tree and you put a little marker right there. And so ultimately your goal is to figure out what is the distance between the marker on your side and the tree on the other side. That would be the width of that river. And you don't want to string some enormous measuring stick across the river or something like that. So what you can do is this: on the side of the river where you stand, walk a certain distance along the river. Let's say you go 100 feet. And then you put a marker right there as well. Some sort of marker, maybe a flag or something like that. And then you go another distance, maybe a much shorter distance, maybe only 20 feet. 20 feet. And put another marker, and then walk straight back away from the river. And while you're doing this, try to line up your location with the marker that you see right here and the tree. So there'd be like an imaginary line going from the tree to this marker to your location, where you back up exactly to a place right here. And then you can easily measure, because you're just on ground over here, that the distance that you needed to back up was, say, 15 feet. Now, how can that be used to judge the distance d across the river? Well, basically what you have here are two similar triangles. This one, which I'm marking in gold, and this one, which I'm going to mark in green. Actually, the gold one, the idea was it's supposed to go all the way to this marker. So let me go back to that. It goes all the way down to here. That's a triangle. And then you have this one over here from the marker, like that, along the river. Those are similar. So in similar triangles, ratios of lengths of corresponding sides are equal. Therefore, the distance across the river d, if I put that in a ratio to the 15 feet, the distance moving away from the river vertically, so to speak, that should be equal to the same ratio of 100, which is the length along the shore for the gold triangle, over 20. D over 15 equals 100 over 20. That gives you, based on that idea of similar triangles, a ratio problem to solve. Sometimes people talk about solving those by cross-multiplying. And so you would say that 20 times d equals, and then cross the other way, 15 times 100. Or, in other words, 20d is equal to 1,500. Then you could divide both sides by 20, and 1,500 divided by 20 turns out to be 75 feet. So the width of the river is 75 feet, all using a trick that surveyors use, and it involves similar triangles.